This fun fact number 26 of the year 2025 has a real wow factor of a story concerning the human side of astronomy. Every week, Space Porn or Reddit publishes fantastic photos from one amazing telescope or another. Sometimes the posts are just hours apart, like these next two photos. The first, a high-mass star forming region, W51A, and the next, a stellar jet blazing on the outskirts of our Milky Way, both by the James Webb Space Telescope. But sometimes we get so caught up in all the amazing equipment that we forget that every single little part of every grand type of scope was created, designed, worked on, and built by humans. Of course, computer programs and AI, both created by human minds, help with the process. But there are thousands of humans delving into the science of astronomy as their job or their hobby every single day. One has to wonder what inspired each of these individuals. Well, it often begins with people like these people. These guys and many others from our club and across the country and in other countries devote many hours to astronomy outreach. It could be an observing night or in the classroom when a child becomes transfixed. It's like throwing pebbles in a pond watching the ripples. One never knows their own influence on another through sharing a passion. So now here's the story. The story is of high schooler Matteo Paz and his cosmic algorithm. In a discovery that sounds more like science fiction than science fact, a local high school student has illuminated the universe with 1.5 million previously undetected cosmic objects, all thanks to a cutting-edge artificial intelligence algorithm he developed himself. Matteo Paz's journey from grade school stargazer to published astrophysics researcher is not only remarkable, it is a testament to the power of curiosity, mentorship, and the untapped potential of youth in the age of AI. His breakthrough has been formally recognized in the Astronomical Journal, where Paz published a rare single-author scientific paper, a feat seldom achieved by even seasoned graduate students, let alone a teenager still finishing high school. But this is no ordinary student, and this is no ordinary story. Paz's interest in the cosmos began early, sparked by evenings spent with his mother at public stargazing lectures hosted by Caltech. These events weren't just recreational, they planted the seeds of a lifelong passion. Years later, in the summer of 2022, that passion would take a dramatic turn when he joined Caltech's Planet Finder Academy, a program designed to immerse high school students in the frontier of astronomical research. It was there that he met astronomer and senior scientist Davy Kirkpatrick, who would become his mentor and advocate. Kirkpatrick, a veteran astronomer whose own journey began in a small Tennessee town, was inspired by a mentor of his own, his ninth grade teacher. You might remember NEOWISE, NASA's Near-Earth Object Wide Field Infrared Survey Explorer, from a previous fun fact. Originally tasked with scanning the skies for potentially hazardous asteroids, the infrared telescope quietly collected over a decade's worth of data, nearly 200 billion data points in total. Though the telescope retired, its treasure trove of information remained largely unexplored, particularly when it came to variable celestial objects, stars that dimmed, flared, pulsed, or flickered with cosmic rhythm. Kirkpatrick had the idea for a summer project for his students to use some of the unexplored data to find variable objects. Paz had no intention of combing through billions of data points manually. His tool of choice was artificial intelligence, specifically machine learning. Enrolled in an elite math academy, he had already been exposed to high-level thinking and algorithmic design. With Kirkpatrick's help, Paz learned the necessary astrophysics and began building a custom AI model designed to detect time domain anomalies, objects that varied in brightness over time. The initial prototype showed promise. In a mere 6 weeks, he had created a working machine learning model capable of identifying patterns even veteran scientists had missed. With assistance from some of Caltech's most accomplished astronomers who understood and could advise on the limitations of NEOWISE, Paz polished the AI program to the point where it analyzed the raw NEOWISE dataset and flagged 1.5 million candidate objects that exhibited significant brightness variability: quasars, variable stars, pulsating phenomena, and likely supernova, among others. The life of outreach volunteers covers many experiences. They may make mistakes or miss something. They need incredible amounts of patience. And sometimes their equipment can get mishandled at public outreach. But regardless, they soldier on, waiting for the next wow as someone sees Saturn's rings in a telescope, or maybe Jupiter's moons in binoculars for the first time. This is a shout out to all of you. What an absolutely amazing thing to do. Share your time, passion, and equipment to introduce others to the magic of our universe. You truly will never know how greatly you have influenced or inspired other human beings. Thank you all.